Hello Year 9, hope you're all doing well during the lockdown. Today's lesson is called Speed of Sound, and our objectives today are I can describe an experiment to measure the speed of sound, and I can explain why sound travels at different speeds through different objects. Last lesson we looked at speed equals distance divided by time and how to use the equation, and today's lesson is going to build up on that knowledge. So imagine it's market day, you're out in Frome, you go shopping and you lose your friend. So you shout out at them. Say, hello, where are you? Something like that. Hello, can you hear me? And they turn round because of course they can hear you. And they call back to you. Sound must travel really, really fast. Because as soon as you shout out, they turn round and they call back. So how fast does sound actually travel? Well, that's what we're going to try and find out today. What is the speed of sound? So sadly it's locked down and we can't go outside and do this. It's a really, really fun experiment to do. It's really easy, just using a saucepan and a spoon and a stopwatch. You can use your mobile phone. I'm sure when you do go back to school, your teachers will want to do this with you. You could do this on your own if you wanted to, but I'm going to go through an animation to show you how this practical is done. So step 1, measure the length of a field using a trundle wheel. Now if you've never seen a trundle wheel before, it's like a meter stick but on a circle, and you walk with it and it goes click, click, click at every meter. So you just count the clicks and you know how many meters you have travelled. So you measure the length just like that and you record the distance. Now you have to use meters for this. So where you started was at 0 meters and the length of my field, I've just measured it, is 300 meters. Step 3. Now, your friend will stand at the 0 meter mark holding a saucepan and a spoon. You can see it over there on the right. And you are going to stand at the 300 meter mark armed with a stopwatch. Step 5. Now, you're going to see your friend bang the spoon before you hear it. So when you see your friend bang the spoon onto the saucepan, you have to start the stopwatch at exactly the same time. So there's the bang, and then you start the timer. So when you see the bang, when you see the spoon hit the saucepan, you start the timer. Now the sound is going to travel across that 300 meters all the way to you. And then when you hear the bang, press stop on the stopwatch and record the time. Okay, so here are some results that I obtained before the lockdown. So distance was 300 meters. That is the diagonal part of Frome Field. First time I got 0.94 seconds. Second time, 1.03 seconds. And the third time, 0.80 seconds. What I want you to do is to copy out the table, work out the mean average time. You should know how to do that by now, to add up the three numbers and divide by 3. And then using speed equals distance divided by the calculated mean average time, work out the speed of sound for me. So I'm going to ask you to pause the video here, copy out the table, and then add in the two numbers there, please. So pause the video now. Right, hopefully you've done that now. And the speed of sound in air is about 330 meters per second. So the speed you should have calculated should have been pretty close to that number. I think it comes out about 321 meters per second, which isn't bad. So here's an exam question example. Looking at the feedback that lots of you have given me, some of you wanted some more exam questions. So this is for all of you that ask for that. So here's a person clapping the wood. So you see the lady in the pink top, she's clapping the wood, and her friend with the brown jumper has got a stopwatch and he's going to time. The sound wave hits the wall and it echoes back. How could you determine the speed of sound this time? So that's all the information you've got. How would you work out the speed of sound? What would you do? Okay, you've got a distance. The lady in the pink to the wall is 480 meters. You can see where the sound wave's going and he's got a stopwatch. how could you determine the speed of sound? So what I want you to do is to pause the video and just jot down some bullet points about what you would do to be able to determine the speed of sound this time. Okay, let's go through what an answer might look like. So the distance to the wall is 480 meters, but the sound wave is going to go from the lady in pink to the wall and then all the way back. So it's 480 meters twice. So that's 960 meters. Now the gentleman in the brown top is going to have the stopwatch. So he's going to measure the time. So when the lady in pink hits the two pieces of wood together, he starts the stopwatch. The sound is going to hit the wall and it's going to come back. So in effect, he's going to hear the echo. And when he hears the echo, he stops the stopwatch. So the time I've put down here on the words on the right is 3 seconds. But you would write down whatever the time that it was. And then using speed equals distance divided by time, we could work out and determine what the speed of sound is. How did you do? If you didn't get any of those notes at all, then please write them in now. You might want to draw a sketch of the picture and then put down some of the words on the right next to your picture. So pause the video now. Okay, let's move on then. So here are some exam style questions. So two students stand 200 meters from a wall. One bangs two pieces of wood together whilst the second starts a stopwatch and stops it when he hears the echo. The time shown on the stopwatch is 1.2 seconds. Calculate the speed of sound. So that's different numbers for the example that we've just seen with the lady in pink and the man with the brown jumper side by side. Number 2, sound travels at 330 meters per second. So how far would the sound travel in 20 seconds, 5 seconds and 0.2 seconds? And number 3, sound travels much faster through wood than it does through the air. Through wood, the speed of sound is much higher, 4,000 meters per second. So how long does it take for a sound wave to travel through a 30 centimeter tree trunk? Okay, so I'm going to go through the answers in a moment, but what I want you to do is to pause the video and have a go at these questions. Number 1 and 2 are fairly straightforward. Number 3 is the tricky one, and there's a deliberate part of that question that's designed to trip you up. So see how you do. Pause the video, please. Okay, let's go through some answers. So number 1, speed is distance over time. Now the distance was 400 meters, 200 meters one way and 200 meters back. So hopefully you got that. So 400 meters divided by the time gives you a speed of 333 meters per second. So if you got that answer, give yourself some ticks. Give yourself 2 ticks for this one. If you did the distance as 200 meters, you only did it one way, just give yourself 1 tick. Number 2. So distance is speed times time. So in 20 seconds, it travels 6,600 meters, 5 seconds, 1,650 seconds, and 0.2 seconds, just 66 meters. So if it travels 330 meters every second, you just multiply by the number of seconds to work out how far it went. Now question 3 is designed to trip you up because it says a 30 centimeter tree trunk. And from our previous videos, we know that distance is always measured in meters. So imagine you made a meter stick, 30 centimeters is not 30 meters, is it? So 30 centimeters is much smaller than a meter, and it's 0.30 meters. So hopefully you might have been able to have done that one. That one was a tricky one. So time is distance over speed using the speed triangle we used last lesson. 30 centimeters converted is 0.3 meters, and then you just do the calculation and there's your answer there. So the purple one was designed to trip you up. Don't worry if you didn't get that one. That one was a tricky one. If you did get it, superstar, well done. So if you just tick off your work and the answers there if you need to write them in now. Right, let's move on then. So this is something that you can do at home. If you've got somebody else at home with you, then you're able to do this. You can do this on your own. So if you haven't, but you will need a really quiet space to do this. So what I want you to do is to gently tap the table. Now if you're sitting just up on a chair or just watching this video, Put your finger on the table and just gently tap it. Tap it so that you can't hear it. Okay, and then put your ear on the table and continue tapping. I bet you could hear it when your ear was on the table. And when your ear's on the table, the sound travels much faster through the solid table than it does through the gas air. So in year 7 and year 8, you learn about solids, liquids and gases. And air is a gas. The particles touch only when they bump into each other. So they transmit sound really, really slowly because they're not able to collide very often and pass on that sound. A solid, on the other hand, the particles are arranged in rows and columns. They're touching all the time, so the sound is able to go particle to particle to particle to particle much, much faster because those particles are touching. So we now know that sound can only travel from particle to particle when the particles touch. So it's almost like, kind of think of it as an analogy, the particle holds the sound, and when it hits another particle, it's able then to pass the sound over to the next particle, a bit like a relay race. In space, there are no air particles, so sound can't travel through space because there's no particles to carry that sound and then bump into another particle and pass that sound on. So when you tap the table, you should have heard it when your ear was to the table because the sound travels through the solid much, much faster. When it's in the air, your finger would have made a sound on the table, but it probably would have hit an air particle and then kind of stopped because there weren't any other air particles it was bumping into at that time to then transmit that all the way to your ear. I suggest that you pause the video, you draw the model of a gas and a solid, and you make some notes about sound travelling faster through a solid and slower through a gas. So pause the video now, please. Okay, so that actually comes to the end of the lesson. Nice quick one this week. So task 1, define the following terms: speed, distance and time. And this means, what do these words mean? 2, how fast does sound travel through the air around you at college? 3, if a sound wave travelled through air for 4 seconds, how far would it have travelled? That's a past exam question. 4, how can you work out how far away a detonation canister is just by watching? So imagine that there's a detonation, like a big bomb about to go off, and you're a very, very big safe distance away from it, maybe 3 or 4 kilometers, so 3,000 or 4,000 meters away. How could you work out how far away it was just by watching it? How would you know without actually having to measure that 3,000 or 4,000 meters? So you might need to design an experiment for that one. And that one's going to hit our first lesson objective. 5, you shout at a friend in Frome Market, and exactly 0.5 seconds later, they turn round. So how far away are they from you, do you think? Is there a mathematical sum you can use? And then task 6, as always, it's our postcard physics. So you just keywords, definition, summary, write out a full speed calculation, and then anything that you are unsure of. Okay, so that's our lesson done for today. Nice quick one, as I said. All right, take care everybody, and tune in next week.